to solve another Leetcode problem. Leetcode 31, next permutation. So for this problem, we want to find the next greater element. So for example, inside of the array, we have numbers like 1, 2, 3. So for the next element, it's gonna be 1, 3, 2 because 132 is bigger than 123, and for the next one it's gonna be 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. But what is the next? If it is 3, 2, 1, so the next is gonna be 1, 2, 3. Yeah. So this is the idea. So basically, we want to find the next greater number. Yeah. So let's just check this example. If we have a number like 4, 3, 2, 1, this has already been the maximum number. So if we want to find the next permutation, so it's going to be 1, 2, 3, and 4. So what about this number? 4, 2, 3, and 1. So basically 4 has already been the biggest number, but what about this 2? This 2 is smaller, but this 3 is bigger than 2. Yeah. This 1 is smaller than 3. So can we just change 1 and 3? Is that okay? It is not, because we want to find the next greater element, but this is smaller. 4, 2, 1, 3. It is smaller than 4, 2, 3, 1. So the next one is going to be 4, 3, 1, 2. Yeah. But how did we get the 4, 3, 1, 2? We should know that if we swap 2 and 3, we can get 4, 3, 2, 1. Yeah, like 4, 3, 2, 1. But after that, we should know that if we change this number from 2 to 3, definitely it is the next greater element, next greater number. But what about this 2 and 1? But this 2 and 1 is too big, because 2 and 1 it is decreasing, it is too big. We want to make it smaller, so we need to change to 1 to 1, 2. Yeah. So finally, the number is gonna be 4, 3, 1, 2. Yeah. But exactly how did we do that? How can we do it for all the cases? We can make a drawing. So if the number is always decreasing, like something like 3 to 1, it is always decreasing. What are we gonna do? We just need to reverse the nums array. So from the beginning, it is 3 to 1, so it's gonna become 1, 2, 3. Yeah. So if this number is always decreasing, so we just need to reverse the nums array. Yeah. But what if it is not? So what if it is always increasing? Yeah. So if it is always increasing, it is also okay. We just need to find the number from the right to the left. If this number is bigger than this number, we just need to swap it. Yeah. We just need to swap those two numbers. So this one gonna be here. This number gonna be here. So after swap, it's gonna be something like this. Let me just remove it. Yeah. So this is something after swap. Yeah, so after swap, this number gonna be like this. Maybe this is like 1, 3, 2. So from beginning, it is 1, 2, 3. So after swap, it's gonna be 1, 3, 2. So this is gonna be the next permutation. Yeah. Up to now, it is okay, but what if it is something like this? Yeah, so this means from the left side, there's a lot of numbers. It's going to be increasing until to the maximum number. Yeah. And from the right side, it is always decreasing until it decreases to some minimum number. Yeah. So the idea is that we want to find the next permutation. Yeah, so let me just use example. So for example, it is decreasing. Maybe this number here, we have a number 2 and 1. So after swap 2 and 1, it's going to become 1, 2. Is that 1, 2 okay? Definitely it is not, because it is even smaller. We want to find the next permutation. It's going to be bigger. Yeah, definitely it is not coming from here. Yeah. So actually, because at the left side this is always decreasing, we cannot find it, so we need to find the pivot. So for this point, we're gonna call it a pivot if we find a number. So for example, this number is bigger than the number at its left side. For example, this number may be 4 and this number may be 3. Yeah, if this number is bigger than the number at its left side, so we're gonna check from the right to the left side until we find a number which is bigger than its left side. This means we've already found the pivot. So the pivot gonna be 3. So this 3, we're gonna call it a pivot. So this is a pivot. Pivot, it means just some swapping position. Pivot, it means this is an important point. We're gonna swap it. Yeah. So currently we are sure. Oh, here this is gonna be a pivot. At the right side, maybe it is some numbers like 2 and 1. Yeah. If we find a pivot, so this means we're gonna swap it. So what's gonna happen after swap? So this is 3, this is 4. So after swap, it's gonna be something like 4 and 3. Yeah, because definitely 4 3 is bigger than 3 4. Yeah. So this means from here it's gonna be 4, and at the right side from here it's gonna be 3. This is after swapping. Yeah. So this number pivoted for at this side it is 3, 2, and 1. But is this the next permutation? It means is that the next number that is bigger than the previous number? So 4, definitely it is okay. But what about 3, 2, and 1? It is not. So this means we needed to reverse it. 3 to 1, we needed to reverse it from 3 to 1 to 1 to 3. So after reverse, it's going to be 1, 2, 3. So this is going to be the next permutation. It's going to be the next number which is bigger than the current number. Yeah, because definitely we are sure after swap, oh, this line gonna be decreasing. Because from the beginning we are checking if it is increasing, we've already found it. It's gonna be a pivot. So this means at this side, if it exists, it must be decreasing. But decreasing is not okay. We need to find the next permutation. So this means we have to reverse it. Yeah. I think if we understand all the simulation process, we need to know how to solve it. So definitely it's going to be 3 steps: pivot, swap, and reverse. So the first step is that we're going to find a pivot. The second step is that we're going to swap with the pivot, and the third step is we're going to reverse after the pivot. So everything is concerned with this pivot. So if we were to solve this problem, definitely we need to remember this is going to be a pivot problem. This is going to be a simulation problem. For the simulation, we need to find the pivot. If we find the pivot, so this problem has already been solved. We just need to swap with the pivot and reverse after the pivot. Yeah. So let me just do the pivot first. We're going to define the pivot to be a noun from the beginning, and then we're going to check from the right to the left side. So this is going to be 0 and -1. So if nums I, so normally nums I will be smaller than nums I minus 1. But if it is bigger, nums I minus 1. For example, if 3 is bigger than 2, so definitely this 2 is going to be a pivot. Yeah. So pivot is going to be I minus 1. And we just needed to break it. Because if we find a pivot, this means that the problem has already been solved. Yeah, we have to break it. Yeah. If we didn't find the pivot, we just need to reverse it. So here, if pivot equal to noun, so this means we didn't find the pivot. So what are we going to do? We just need to reverse the nums, because we have to solve it in place. So we're going to directly use the nums.reverse. This is in place. and we need to have a return. Yeah, so this means we don't need to do anything if the pivot is none. But if the pivot is not none, so this means the pivot is gonna equal to I minus 1. So this means we need to start the swap. Yeah, so let me just copy and paste. So for I in range length nums minus 1 to pivot. If nums I is more than nums pivot, so this means we already find it, we just need to swap it. Yeah, nums I with nums pivot gonna equal to nums pivot and nums I. After swap, we just need to break it immediately because we've already finished what we are doing. If we find it, we're gonna break it immediately. We're gonna swap and break it immediately. We just need to find the number from the right to the left. If we go back to the drawing, from the right to left, we just need to find that number, which is gonna be which is gonna be bigger than pivot. So for example, this is pivot, this is bigger than pivot. We just need to find the number which is bigger than pivot, and then we're gonna stop it. Yeah, because there can be many numbers. It's gonna stop. It's gonna swap if we didn't break it. Yeah. Our idea is that we just need to swap with the pivot. So this means we have to break it. So after swap, everything is okay. We just need to reverse it. Yeah. So because we need to reverse it in place, so we have to use two pointers. It's going to be easier. And from the left side, it's going to be pivot plus 1. And the right side, it's going to be length of the nums minus 1. Yeah, so this means we're going to reverse after the pivot. So nums L, nums R gonna equal to nums R and nums L. And from the left side, it's going to plus equal to 1, and from the right side, it's going to minus equal to 1. So this is the reverse. Now let me just run it to check if it works. As you can see, it works. Yeah. So normally, if you didn't analyze the problem like that, if you didn't use a similarization, if you didn't know how to use a pivot and then use a pivot to swap and reverse, basically, I mean, you have to remember all the steps. If you didn't remember the steps, or if you didn't know all the simulations of the problem, definitely you cannot solve it so easily. You're gonna make a lot of mistakes. Yeah. So basically, you need to remember there's gonna be a keyword which is gonna be pivot, and then definitely you can solve the problem. Now let me just submit it to check if it works. As you can see, it works and it's pretty fast because the time complexity is O(n) and the space complexity is O(1) because we have to solve it in place. So this means we didn't have any kind of a return. Yeah, we just solve it in place, and we didn't use any actual memory. As you can see, we didn't use any actual memory. I think that's all about it. Thanks for watching. See you next time.